Welcome again, once again, to this learning channel. Today we'll be looking at the proof of Demorgan'S theorem. The proof of Demorgan'S theorem. So don't forget, in the previous video we stated the Demorgan'S theorem and in two parts. So one, we say it is to be equals to, break the sign and change, break the bar and change the sign, A bar plus B bar, and the second side of it is A plus B all bar, and then we say it is equals to, we break the bar, A bar, we change the sign, multiply by B bar, and this is Demorgan'S theorem. Now we want to prove if this law is, or this theorem is actually true and correct. So we begin by looking at, for us to be able to prove this for any theorem for that matter, for any theorem where we say, for example, we say x is equal to y, we must be able to show that x bar y multiplied by y is equals to 0, and that x bar plus y must be equal to 1. If we are able to show that this holds true for Demorgan'S theorem, then Demorgan'S theorem we have successfully proven. So we can use this to prove Demorgan'S theorem. So for example, we say A asterisk B, or A multiplied by B multiplied by A bar plus B bar should be equals to 0. Remember, here is our x, and here is our y, and this is our x, and this is our y. So the multiplication of both of them should be equal to 0. You may be wondering that this x has a bar here. Yes, the bar has been cancelled out by the involution theorem, because we have double bar, and then it will give us the natural order of the element. So this is why we have this without this big bar over it. Yes. So let us see if this will actually give us a 0. So from here now, we can actually apply the distributive law. We can apply the distributive law. That means we distribute this element over this, and this will give us A bar, that is this A bar, into the bracket of A multiplied by B. And then we have the plus, that is this. Of course, then we distribute this over this, just like, let me just indicate, this over this, and then this over this. Yes. And then we have B bar into the bracket of A B, and the law applied here is the distributive law. Okay, having said this, we can apply the associative law to each of these terms, each of these terms, to say, since this is, remember in the previous video, associative law, we say the arrangement does not really matter, so we can actually have B into A asterisk A bar is the same thing, and then we have plus A into, bring the A out, B asterisk B bar. So this is associative. Associative law. Then of course we have what we call the complement. The complement can apply to the terms in the parentheses, where we have the A multiplied by the inverse, or the negated version of the element. So we have, and that gives us a 0. So we have B multiplied by 0 plus A. B multiplied by B bar is going to give us also a 0. And the law applied here is the complement law. Complement law. Then of course we look at nullity. Nullity, remember in the nullity law, when you multiply an element by 0, you're going to get 0. So we have B multiplied by 0 is 0, plus A multiplied by 0 is 0, and we call this null. Nullity. And then we have the identity law. When you add an element to itself, 0 plus 0 is going to give us 0, because we call this the identity. So having gotten 0 as our element, remember where we started from, we want that x bar multiplied by y to be equals to 0, and that is what we have gotten. So that is one way to prove Demorgan'S theorem, this particular one, to be true. And then before we conclude whether it is true or not, we need to check if it is also true for these x bar plus y to be equals to 1. When we add them together, will they be equal to 1? Let's see. And so we want to prove this to be, that is in looking at this one. So we have A asterisk B plus A bar plus B bar to see if it's going to give us a 1. Remember, this is Boolean algebra. This is Boolean algebra. So we see, and then we say this will be equals to, we can apply the distributive law, distribute this over this, or distribute this over, yeah, we distribute this over this, and then we're going to have A, this A plus this, then we have A bar plus B bar, then multiplied by, so this multiplication, then we have B distributed over this, plus A bar plus B bar, and then we say the law is distributive. Distributive law. And then we look at it, we can actually apply another law, the associative law. That means the order, the arrangement does not really change the result. So we can rearrange this to say we can bring the B bar out and bring the A in. So we have B bar plus A plus A bar. doesn't really change the expression. We just rearranged. Then our multiplication, and of course we can do the same thing here to say we bring the a bar out, a bar plus b plus b bar, and then we call this the associative. It is important to state the law you are applying for easy understanding. It's important to state the law you are applying for easy understanding. And then we can apply the complement law. The complement law. Remember, the complement law can apply to these terms in parentheses because this is addition of the inverse, additive inverse of both elements, and that is going to give us 1. So we have here b bar plus 1 and multiply by a bar plus 1, and this is what we call the complement law. So having applied the complement law, we can now apply the nullity law. The nullity law states that when you add an element to a particular 1, you can get 1 as the element. So b bar plus 1 is going to give us a 1, multiplied by a bar plus 1 to give us 1. We call this the nullity. And then by identity, when you multiply 1 by 1, you're going to get 1. We call that identity. So that is our final solution. So we have proven the two requirements to show that this part of Demorgan'S theorem is true. We have seen that x bar plus y is going to give us a 0, just as we have this multiplied by this to give us a 0, and we have proven it here. In the same vein, x bar plus y is going to give us 1, and we have shown that here, x bar plus 1 to give us 1. Now I will want to task us to prove the second side of Demorgan'S theorem on our own, and in a subsequent video we're going to have to see the proof of this here in this channel. But before we get there, you may want to lay your hands upon it and see if you can prove this using these two theorem the proof requirements. Thank you very much for watching. God bless you.